For this part, I'm going to finish up the work on rational expressions, in this case adding and subtracting, and then I'll roll this into solving some rational equations. All right, so I'm going to go with letter F here. All right, so I'm going to factor both of these denominators to see what my common denominator will be. I think the denominator on the right is a little bit more straightforward to factor. This is the difference of two squares, so 3x minus 5 and 3x plus 5. And this one, I went ahead and just wrote 3x and x, and then I just, if you need to use, the symbol to help you figure this out, the factors of negative 60 to add to 7, and then split the middle, you can. I went ahead and just did guess and check for each of these here. So I did minus 5 and plus 4. When I multiply negative 5 times 4, I get negative 20. 3x times 4 is 12x. Negative 5 times x is negative 5x. Putting those together gives me positive 7x. But again, if you used this tool over here and split the middle, you get those same things. So my common denominator is going to be 3x minus 5, 3x plus 5, and x plus 4. All right, so all of those, I need to make sure that both of these denominators have them. So when I look at this first one, I'm going to write down x plus 2 over 3x minus 5 times x plus 4. So the one this needs is going to be 3x plus 5, top and bottom. And then when I write down the other one, this one is going to need the x plus 4, top and bottom. All right, so I'm going to now write it as one fraction with that common denominator. And I'm going to distribute in my numerators. All right, so distributing here, right, just foiling, it's going to give me 3x squared. And that's going to be plus 6x plus 5x, which is plus 11x, plus 10, and then minus. And I put it in parentheses because I do need to subtract all of these terms. So x times x is x squared. X times 4 is 4x. 1 times x is 1x. Together that makes 5x. And then 4 times 1 is 4. All right. If you need to change that to addition and then make all the signs the opposite, you can. I'm just going to do subtraction. It looks like all of the signs are positive, so it shouldn't be too difficult to just subtract the common terms. Again, there's my common denominator. So 3x squared minus x squared is 2x squared. 11x minus 5x is 6x. And 10 minus 4 is 6. Now you'll notice that they have a GCF of 2. If you took out that 2 and made it 2 and then all times x squared plus 3x plus 3, that's also fine. You're not able to factor that, so there's no reason to keep going, but if you did, it would not be wrong. So this is going to be my answer for letter F. All right, let's go to G. G is more of your traditional kind, where the common denominator, since they don't have anything in common, is just the two of those multiplied together. So I'm going to just copy down my problem. So this one needs the x minus 2 on top and bottom. And this one over here needs x minus 5. Now because this has less terms, when I write my common denominator and then distribute in the numerator, I'm going to get 4x minus 8. And I would recommend distributing this subtraction when you distribute the 5. Again, you don't have to. I did not do that on F because I had a lot more terms with that quadratic trinomial. But this is a little simpler. So I'm going to multiply negative 5 times each of those to write minus 5x and then plus 25. And then I'm just going to add my like terms. So my new numerator is going to be negative x because 4x and a negative 5x is negative 1x. And negative 8 plus 25 is 17. All right, last one on this page, letter H. Again, I'm going to factor. This is x minus 2 times x minus 2. This one on the right is another difference of two squares. So my common denominator is going to be my denominator on the left. And you'll notice the denominator on the right already has one of those x minus 2s. So you don't need to put another one, but you do need to put the x plus 2 since the denominator on the left did not have that one. Okay, so copying this down, I'm going to multiply the one on the left by x plus 2 on the top and bottom. And then the one on the right is going to need another x minus 2. All right. This is addition, so I don't need to worry about that whole distribution issue. There's my common denominator. I don't care the order, right? If you wrote x plus 2 at the front or x plus 2 in the middle, it doesn't matter. So distributing x plus 2 and x minus 1 is x squared. And then that's going to be negative 1x plus 2x is plus x minus 2, plus 3x times x is 3x squared. 3x times negative 2 is minus 6x. And we'll combine like terms to get 4x squared minus 5x minus 2. Put the CD in the bottom, and you are finished. If you wanted to try to factor that numerator, you could. Factors of negative 8 that add to negative 5, I don't think those are going to exist. So we are finished with that page. Okay, let's move into solving some rational equations. The key thing here is when I do this, I actually find the common denominator, but the tricky part compared to the ones that we just finished in the last video and to start this video is that when I do these, I do a completely different strategy. So I don't actually think like, oh, what does it need? Which you can totally do that strategy. It's not wrong to do that here. But mathematically what I do is I take the common denominator and multiply every single fraction that I have in my equation, just the numerator by that common denominator to cross out / eliminate any denominators. So that's my strategy when I do these. Now A is not that strategy for me personally, because this just looks like a proportion when I have one fraction on each side. So I'm just going to multiply across, so 3 times x minus 1 and 5 times x plus 2. And what I learned from middle school is that with proportions, those cross products must be equal to each other, okay? So distributing 3x minus 3, 5x plus 10, this gives me 2x, and that's going to give me minus 13. So I get x equals negative 13 over 2. If you'd like to write it as a fraction, you can. Or excuse me, a decimal, you can. It's your call. Now, when I check these, because it says to check for any extraneous solutions, I'm looking at the original equation, and I'm looking at my denominators. And I ask myself, okay, would negative 13 halves, all right, which is negative 6.5, if I plug that in, would it make 0 in the bottom, right? And it would not. Right, if I checked it and wrote 3 over negative 13 halves plus 2 equals 5 over, I'll put here, I'm checking, 5 over negative 13 halves minus 1, you'll notice that each of these would not be 0. So this is okay, all right, but you always want to check with rational equations to see if it makes 0 in the denominator, because if it does, it is an extraneous solution, so I should cross it out. So make sure you're checking when you're doing these problems. Okay, let's do B. All right, so B is going to be where I do this new strategy. I'm going to factor this denominator, this last one, to be x and x plus 1. So you'll notice that they share the x plus 1, these share the x, so my common denominator is going to be just x times x plus 1. So I copy down this original equation, and I leave space. Notice how I wrote the factored version there, to multiply every single numerator by this common denominator. So it doesn't matter what the denominator looks like, they all get the same one. And the reason is that if I went now and crossed out the common factors, you would see that all of my denominators are gone. So in this one, what's left is x times x, which is x squared. What's left here is going to be 5 times x plus 1, which is plus 5x plus 5. And what's left here, if you look, is just the 1. There's nothing else left, so equals 1. All right, and this now becomes an equation you've solved many times before. So moving the 1 over to set this equal to 0, I get plus 4. So I'm looking for factors of 4 that add to 5, which is x plus 4 and x plus 1, setting them each equal to 0. I get x equals negative 4 or x equals negative 1. Again, you should check, right? If I plug these into the original, I would get x over negative 4 plus 1. I don't know why I wrote x, I apologize. Negative 4 over negative 4 plus 1, that's okay. Plus 5 over negative 4 equals 1 over negative 4 squared plus negative 4. None of those denominators would become 0, so this one's okay. So x equals negative 4 works. If I did this for negative 1, you should have alarm bells going off in 2 of these cases, but it just has to happen one time. Literally the first fraction that I plugged it into made 0 in the bottom. So this one is not going to work for x equals negative 1, so make sure you cross it out. Right? You don't have to write this, but that is what is called an extraneous solution. Okay, so make sure you're checking on doing these. All right, next one. Again, factoring. X plus 3, x plus 1. You'll notice that the other denominators are each of those factors, so the common denominator is the 2 of them multiplied together. So I'm going to copy down this problem, and I'm going to multiply all 3 of these fractions by that common denominator. So x plus 3 times x plus 1, x plus 3 times x plus 1, and x plus 3 and x plus 1. Now again, the whole point is to cross out with my denominators. Everything crosses out here. Cross out that one. All right, so here's what's left. I'm going to multiply the 2 and the x plus 1, which gives me 2x plus 2. This is the tricky part. This is where mistakes happened on the test. I have to subtract both of these terms. So if you want, you can write minus and then put it in parentheses, or you can do that distribution right away, your call. And then for the last fraction, I'm multiplying 5 and x plus 3, which is 5x plus 15. All right, now I'm going to do that distribution to write minus 3x minus 5. This is a linear equation, so I'm just going to get my x's to one side. 2x minus 3x is negative x. 2 minus 5 is negative 3. Getting my x's to one side gives me 6x over here. A negative 3 and a negative 15 is negative 18. So x equals negative 3. Okay? Again, we need to check from the original. So I'm going to write 2 over negative 3 plus 3 minus 3 times negative 3 plus 5 all over. I have negative 3 squared plus 4 times negative 3 plus negative, or excuse me, that's just plus the 3 in the problem. If you're wondering where I'm getting this, I'm just plugging it back into the original. Equals 5 over negative 3 plus 1. And again, right away, this made 0, and it doesn't matter because if it just makes 0 one time, you can finish. But if you looked on this one, it would also make 0. In this one, that would be 9 minus 12 is negative 3 plus 3 is 0. So this is not going to work. So make sure you cross it out. All right, let's do one more, and then I'll pause this video and start a new one on graphing. All right, so last one. So this one, my CD, I only have one of these denominators here, so that's easy enough. It's going to be x minus 1. The tricky one with this one is that I don't have a denominator for this term 2, so I put it over 1. And I'm going to multiply every numerator by x minus 1. Now it's definitely going to cross out twice here. So I'll have x plus 1 equals, remember I need to multiply the 2 and times the x minus 1 to be 2x minus 2 plus 5. So that's going to be, I'll combine like terms over here, 2x plus 3. So x equals negative 2. All right, don't forget to check. I'm going to check by plugging into the original, which was negative 2 plus 1 over negative 2 minus 1 equals 2 plus 5 over negative 2 minus 1. So if I look at my denominators, negative 2 minus 1 does not make 0, so this is good. All right, guys, that's it for the rest of those simplifying expressions, the rational expressions, the adding and subtracting operations, and then I did some solving. Make sure you know that how to do these different strategies on this, because I know it can be tricky, and this is stuff that we've been working on in our review days. So come see me if you have any questions.